Okay, so let's say I have a bag, and inside this bag, I have 10 red marbles, I have 4 black marbles, and 6 yellow marbles. All right, so therefore, the probability of me, if I was to pull out one marble, all right, without looking, so I just pick randomly. So the probability of me getting a red marble is going to be equals to what? How many reds are there? How many of my outcomes can be red? 10. Okay. And then what is the total number of my outcomes? It will be 10 plus 4 plus 6, which is equals to 20. So the probability of me getting a red marble is going to be 10 out of 20. The probability of me getting a black marble is going to be 4 out of 20. Okay, the probability of me getting a yellow marble is going to be 6 out of 20. Now, let's say, for instance, okay, you were asked to find the probability of, okay, you're choosing 2 balls or 2 marbles, all right? And those marbles, one is red and the other one is black. Okay, so when you pick out your first ball, you see the color, you note the color, right? And then you replace it, you put it back into the bag, all right? So what happens now? We actually then say they are 2 independent events. Why? Because the chances of me getting a red ball is the same as the chances of me getting a black ball, in the sense that my outcomes remain the same because I have still got 20 balls. So even when my probability of getting the red ball is 10 out of 20, okay, and I multiply it by the probability of me getting a black ball, which is 4 out of 20, the number of possible outcomes is still the same. So which tells me that me getting a red ball is not going to affect me getting a black ball. All right? By that, what do I mean? So let's say, for example, I did not replace the first ball. Okay? So let's say now I did not replace the first ball. Okay? So I did not replace the first ball. So here my probability is still going to be 10 out of 20. Okay? But by me taking out that ball, it's no longer in the bag. By the time when I go and pick my second ball, all right, how many balls are left? How many? Because I took out one, right? So I'm left with 19 balls, isn't it? Okay. And then out of that 19, how many then can I say is black? So it will be 4 out of 19. Okay. So here, me getting a black ball was affected by me not replacing the first card. So this here is a dependent probability. Independent, then this here, my denominator, my total number of outcomes would have remained the same. But because now I took out the marble and I did not replace it, then my total number of outcomes now is reduced to 19. And then I have 4 black balls, 4 outcomes. All right. Let's say, for example, you were asked then to find 2 Okay, let's stick to the reds. So let's say you were asked to find 2 red balls. Okay, so the first one, we're saying here, I am not replacing the first ball that I take out. Okay, so I'm not replacing the first ball that I take out. So this one is still fine. My probability is still 10 out of 20. But now when I take out the red ball here, how many possibilities do I now have? My total number of outcomes is still 19. But how many red balls are remaining? So the remaining red balls here are going to be 9. Because here I did not, yes, I had 20 balls and I had 10 outcomes of getting a red. And then I took out one of the outcomes when I didn't replace the marble. All right, so now I'm left with 19. And if I took away 1 red ball, then I'm left with 9 red balls. Okay, so that's why it's 9 out of 19. If here I took out my first ball, okay, then I put it back into the bag before I pick my second ball, then what are my chances of me getting a red? My outcomes have remained the same. Do you see that? Because I put the ball back into the bag. And now here still as well, I still have 10 red balls. So this is an independent event. Why? Because my second event is not affected by the first event. Whereas where the previous example, we wrote it as it affected the outcome. Sorry, that's what I wanted to say. It affected the set of possible outcomes, and that's why you were sitting with 9 over 19. So when you're talking about dependent and independent events, we write them like this. The probability of A and B occurring is equals to the probability of A multiplied by the probability of B. So this is if it's independent. Remember, I replace the ball, I replace the card. It goes back into the pack. Okay, or it's the probability of A multiplied by the probability of B following A. I don't replace the card. I don't replace the marble. So this is a dependent variable. So it's very important for you to read the question and understand what is being asked of you. So when they say the probability of A occurring and B occurring, then you know you must then decide to see if it's independent or dependent.